Hi everyone. And so by now you have finished chapter 16. And so what we want to do today is look at some problems from chapter 16 with the confidence interval for proportions. And so let's look at problem 1. Here we have a poll that was done in November. This poll took a random sample of 799 U.S. teens about the internet usage. Out of the 799 teens, 49% of those teens reported that they had lied about their age online to gain access to websites and online services. And so what we want to look at first for part A is what does that 49% actually mean? And so that 49%, if we look back, there's our p hat. And so what is that telling us in context of the problem? And so why don't you think about what that 49% is saying in context of the problem? And so that 49% or 0.49, that is telling us that 49% of the 799 teens in that sample said they had misrepresented their age online. And so remember, this p hat is just coming from the 799 teens. It's not saying it's for the whole population. If we took another sample of 799 teens, that 49% would probably change. And so it's just for this sample that from 799 teens, 49% lied about their age. What we want to do next is from that p hat of 0.49, we want to calculate the standard error for p hat. And so remember to find the standard error for our p hat. It's going to be p hat times 1 minus p hat divided by our sample size and take the square root. And so what you want to do is you're going to have 0.49 times 1 minus 0.49 divided by 799. That's our total amount of teens. And then you want to take the square root of all of that. And so why don't you pause the video, take your calculator out, and try to find that standard error there. And so hopefully you found the standard error, and I believe you should get 0.0177 as your standard error. And so let's just think, what is that standard error is telling us in context of that problem? And so after you found the standard error, stop and think of what is that standard error trying to tell us. And so the standard error is our estimate of the amount of variation from sample to sample when we asked 799 teens whether they have lied about their age online. Remember, we do not know the population proportion. We do not know what p is, but we can use the sample proportion p hat to help us estimate the standard deviation of our sampling distribution, and so we can use the standard error. And so what you want to look at next, so let's look at problem 2. Let's say we are given a confidence interval. And so here, let's say 95% for this confidence interval for the number of teens who lied about their age is between 45.6% to 52.5%. And so we're going to keep looking at problem 1 with our sample size of n equals 799. Our p hat is going to stay as 0.49. But let's say we found a 95% confidence interval, and this is what we got. What is that confidence interval telling us right here? And so pause the video and think, what is this confidence interval that we are given telling us in context of the problem? And so we can interpret this interval as saying we are 95% confident that the true proportion of all U.S. teens who lied about their age online is between 45.6% and 52.5%. And so what we're saying is we're 95% confident that P, the population proportion, is somewhere between these two values. We don't know if we're right, but we're 95% sure we have captured the true population proportion. It's somewhere between 45.6 and 52.5%. And so that's all you can say about the confidence interval here. And so what does this 95% actually mean? If we were to conduct many random samples of 799 teens and we found the confidence intervals for each of them, and so let's say we did 100 samples of 799 teens, and for each for all the 100 samples, we found a 95% confidence interval. What we're saying is about 95% of those intervals will contain the true population proportion of all the teens who lied about their age. And so 95% of the time, we would have captured the true population proportion. That is what that 95% is trying to tell you. And so let's look at another problem. And so it's kind of a long problem. It involves politics. But let's just say that at this college they conduct an annual poll about their opinions for Wisconsin. And let's say in fall of 2011, a survey asked a random sample of 402 adult people from Wisconsin whether they think things in the country are going in the right or in the wrong direction. From the 402 adults, 66 said that things were going in the wrong direction. And so what you should do is pause the video. Let's write down that our sample size is 402 and that this 66% is coming from the 402, and so that 66% has to be our p hat. And so you should write those two numbers down before we continue on. And so what we want to first do is, let's say we want to calculate the margin of error for a 90% confidence for the proportion of all the adults in Wisconsin who thinks things are going wrong in the country. And so, remember when we look at margin of error, what you have is your critical value, Z star, times your standard error for your p hat. And so here we want to look at 90% confidence. And so remember 90% confidence is 1.645. And we're going to times that by the square root. And so from the previous slide, it was saying 66%. And so p hat is 0.66. And then hopefully you wrote down the sample size. I believe the sample size was 402. And so you want to find the standard error first. Then you want to times it by your critical value, 1.645. And so why don't you pause the video and find that value there. And so hopefully you found the value, and I believe you should get 0.039. That's a 3 there. Doesn't look like a 3. But let me just fix that a little bit. There we go. And so that's what you should get for your margin of error, 0.039. And so let's just think about this. This is our margin of error for 90%. Do you think if we did this for 95%, would the margin of error be bigger or smaller than the 90%? And so what I am asking is for the margin of error, would it be larger or smaller for 95%? Well, for 95% confidence, the margin of error would be larger. Think about this when we look at our critical values. When we look at 95%, the critical value, Z star is 1.96. 90%, your critical value is 1.645. Remember, each time you go up in your confidence level, the wider your confidence intervals are going to be. Your critical values are getting bigger as well. And so 95%, its margin of error will be larger than a 90% confidence interval. And so what we want to do is look at just one more problem from this chapter. And so we're going to go back to problem 3 that we were just looking at. And so with the people from Wisconsin, he thought the direction for the country is going in the wrong direction. What we want to look at is the assumptions and conditions. We want to make sure they are met. And so remember, we're looking at p hat is equal to 0.66, I believe. Yes. Our sample size was 402. And so here we want to make sure everything is getting met, that if we wanted to find the confidence interval, we could do so. And so the first thing we want to check is to make sure they took a random sample. And so you could go pause the video, go back and see, was this a random sample? And so if you went back, you should say, yes, they took a random sample. And so that's good to go. What we want to check next is independence. And so we want to take our sample size times the sample proportion p hat. And that should be greater than or equal to 10. And so what you want to do is you want to take our sample size 402 times 0.66 and see, is that greater than or equal to 10. And so pause the video and find that number there. And so you should get 265, and that is definitely greater than 10, and so that checks out as well. And then our third is we're going to take our sample size times 1 minus p hat, and that needs to be greater than or equal to 10 as well. And so you want to take 402 times 1 minus 0.66 and make sure that is at least 10 or more. And so I believe if you find this value and you round, you should get 137. That's greater than 10. And so that checks out. And so our conditions, our assumptions have been met. We can go on with the problem. We can find the confidence intervals because all the conditions have been met. And so you want to make sure you check these conditions first thing. Make sure each of them have been checked out. And so for our last problem, what we want to do is we want to find how many people would be needed to survey if we want to find a 90% confidence interval, and we want to ensure the margin of error will be less than 2%. And so we can find our sample size when we know how much confidence we want and how much we want our margin of error to be. And so when we look at this and we're trying to find this, we're going to have our sample size equals our sample proportion p hat times 1 minus p hat times our critical value z star. That's divided by our margin of error. And you want to make sure you square when you divide. And so what we want to do is go back and remember from this problem, our p hat that they had was 0.66. And so we're going to have 0.66 times 1 minus 0.66 times, here we're looking at 90%, remember 90%, its critical value is 1.645 divided by the margin of error. Here we're looking at 2%, and so 0.02, and you want to square that there. And so why don't you pause the video and find that value there. And so hopefully you have found that value, and I believe you should get 1,518. And so right here, this is how many people should be surveyed if we want 90% confidence and our margin of error to be less than 2%. And so when you're finding the sample size and you're given the confidence level and your margin of error, here's the formula you want to use to find that there. And so what you should do is just look over this video, look over these problems, and work on them yourself, and check to see that you can do these problems here.